Hi everybody, welcome back another technical demo. My name is Daniel. Today I'm going to showcase how to automate your application metric and analyzing with a container Java file recorder. So as you probably know, there are lots of JDK platform or tools to develop your application in Java world. And OpenJDK, one of the top choices for many Java developers for many years to implement your application. But you might have one concern: how to analyze, how to gather the application data or metrics to observe or trace to performance issue in your production environment. So in order to address that kind of problem, maybe you needed to buy some third-party solution or third-party tools to visualize the application data metrics from memory and heap, even some performance data, and then you will figure out and prevent unexpected error even in production environment. But OpenJDK, maybe some people have some thought. OpenJDK doesn't have a good feature to address that analyzing tools, something like that. But don't worry about that any longer. So JDK, Mission Control, and the JDK File Recorder back in 2008 was a fully open source tool, and you can build on in Java Virtual Machine after OpenJDK 8 or old version from OpenJDK 11 onward. Back in 2018, the JDK Mission Control can be running on desktop standalone application environment. So developer just can install your JDK Mission Control and just record your JFR to analyze your application metric and try to improve performance issue or something other potential problem on your Java application. But now we have moved forward to new immutable infrastructure like a Kubernetes or Red Hat OpenShift container platform. So we need to find more container first analyze tool, just like a JDK Mission Controller or a JFR recorder. So the ContainerJFR, today I'm going to talk a little bit about with some nice demo. So ContainerJFR is a new project invented by Red Hat, brings the Java developer to have the same capability from their desktop to analyze your Java application to your cloud environment such as Kubernetes, because this will be deployed as a container, actually it's a sidecar alongside your application. Okay, let's get into the demo how ContainerJFR works. So here is my OpenShift container platform. I just created a new empty project, ContainerJFR-demo. And then first of all, we need to install ContainerJFR based on operator, which is really awesome. So you just go to find the operator and then just create based on the latest version. Still is experimental status. So I'm going to use alpha version to install the operator. So it takes a few minutes to install the application. So once you install the ContainerJFR operator, you can create the ContainerJFR or file recorder, or you can actually have recording. So for example, you can click on ContainerJFR creation, you can put in the ContainerJFR name and a label, but also you can create a file recorder here and also recording. So once you deploy that, I just switch the existing project because it's already installed the ContainerJFR and operator here. ContainerJFR is a containerized JVM which runs as a sidecar alongside your OpenJDK application. So it also automatically selects the best strategy to discovering your JMX enabled application. I'm going to talk a little bit about how to set up the JMX enabled configuration on your application side. Okay, so I'm going to deploy sample application to gather and analyze your application metrics. In order to, I'm going to switch to right project. I'm going to deploy one of the Java application based on Vert.x. Here is a Fibonacci application based on Vert.x. So I'm going to export the endpoint to access the application. And also I'm going to deploy the JMX using OC command line. And we deploy the JMX container as well. So in OpenShift or Kubernetes environment, you have to create the service for your application development and add export port to your service objective. By default, the ContainerJFR use port 9091 for JMX, but you can actually use any port number, but you have to use specific port name like a JFR-JMX. So that's why we're gonna patch the service of JMX listener here. So using the 9093 port and using JFR-JMX. Okay, go back to OpenShift developer console. You can find the Vert.x JMX already deployed, and then try to access the endpoint and click on start button, which allows you to generate the Fibonacci numbers because we're gonna put in some workloads in the application. So here is the ContainerJFR dashboard. In order to log in, we need to token from your OpenShift cluster. So using OC whoami command line, we gotta find our token information and try to log in here. You can find the target JVM. So first of all, the Vert.x Fibonacci demo is our one of JVM application. As you see, the ContainerJFR by default supports JDK file recorder event template. So first of all, the default template is continuous and a profile and all, which preset the event types and configuration properties to be supported. When you use event template, you can simplify the task code capturing the important application metric in your application side. So for example, we're gonna create a new recording here. The name of the recording name like a Vert.x underscore recording, and the duration, you can put in the duration like a 2 minute or 20 second. I'm gonna put in the 2 minute, and event profiling, just leave the default. Our new custom recording is just created. It will be recorded in next 2 minutes. And then you can actually download the recording or report for analyzing more deep dively. So you can download the JFL recording and you can open the editor and just find out more detailed metrics here. So one of the beauty of the ContainerJFR provides the Grafana dashboard. You can export the data to external Grafana data, and then you can change the duration and some condition. You can find my local machine CPU and memory, and also when you get started the recording time and recording duration like a 2 minute. And there are a lot of information and metric here. CPU load and the message threshold, this heap usage, you can find more detail in Grafana dashboard. Okay, so let's try to deploy a new application like a Quarkus application, which he also deployed based on JVM. We're not gonna use native compilation at this moment. Okay, here I just created a new Quarkus application project just generated based on Maven command line, and then we're gonna just package this application right away using Maven command line. The Maven package, this is a race to Quarkus 1.12, which supports a fast start by default. It's a pretty great improvement in your fast runtime and the fast response time. You can find more information in the Quarkus 1.11 in Quarkus.io website. So we're gonna run this application to make sure the application is working well. So the running is a new application. Just go to try to access endpoint like using curl command, or you can also go to web browser. So I'm going to use a curl command, the localhost 8080 and the endpoint hello, which will return hello. That's easy, just like a hello world program. And then we're going to build this application using binary build strategy of OpenShift container platform. And once we finish the create a new build, and next step we're going to start the application build from the fast start application target directory under Quarkus-app directory. We're going to package this application based on OpenJDK 11 and then push it into a containerization inside the OpenShift. So next step, we're going to create a new application using OC command line once again. But one thing you should know that we need to add the Java option is required. For example, the JMX remote port and the RMI port, and we're not going to use authenticate, and also SSL and all registry is ports. This is a really important thing. You need to add the JMX remote port 9091 for Java Discord for using Java Discovery protocol I already mentioned earlier. Okay, so we just create a new application based on the binary build container image. And last step, you're going to expose the service to access endpoint here. So now we have a Quarkus application here, and then go to log file, and then just make sure your JMake Java option is included when you run your application, specifically JVM runtime. All right, it looks good. And go back to the topology view. So let's try to open URL for endpoint to access the endpoint. This application is deployed well with the functionality. So hello, that's easy, just like we saw in a local environment. So one thing we have to do is add here JMS RMA, the key name your service port 9901. Okay, so pretty good. And let's try to make some workloads in our Quarkus application. Keep invoking the endpoint, and then go back to your ContainerJFR. Now you have the Quarkus JVM is automatically detected. And then let's try to create a new record based on all event template to create a new custom thing. And then we just put in the duration 2 minutes, and the name we're gonna add like a Quarkus underscore recording. All right, it's all set, and then create a new recording here. And you can actually add the advanced option like a minimum size to store your disk space, and then and also the maximum space as well. So this custom recorder will be recorded the next 2 minutes, and then when you go back to Grafana dashboard, you will find the detail your all application metrics and data. Okay, it just stopped it. Okay, let's go to Grafana dashboard here. So go to dashboard here, you can find the same my local environment detail, and also you can find the CPU load and heap usage, and also metaspace DC threshold and Java thread statistics. So based on this, the metrics, you can find the unexpected error or some kind of performance issue, but also you can compare existing Java application performance such as Vert.x or Spring Boot or JBoss EAP, etc. So let's try to download report based on HTML file. You can open it in the web browser or any editor. You can find more detailed information. You can share this HTML report with your team to analyze your metrics for your application. So you can find the GC or the JVM internal or Java application itself, and environments where you executed this analyzing your ContainerJFR. Hope you enjoyed this demo. One thing you should be aware that this ContainerJFR is still on the development stage, so we all do best to release 1.0 for next few months. If you have any question around this ContainerJFR, please feel free to reach out to me directly. I'm more than happy to address your question. And thanks for watching. Have a good rest of the day.